Hi everyone, in this video I'm going to go through comparing interest and also just we'll have a look at some test and exam style questions for financial. So I'll just start with this. You've got your notes, and on page 6 of your notes we've got this question here, so I just wanted to go through this with you. First of all, it says Oliver invests $50,000. So whenever we're looking at this, let's get our highlighter out or underline. Let's do, here we go, we've got $50,000. So we need a principal, we need a rate, and we also need a time period. So we've been told that it's compounded quarterly. We're looking at 4 years, and it's 12% per annum. So that first of all, we want to work out the rate per quarter. So you can see that the rate per quarter, you get 12% a year, but what is that a quarter? It's 12% divided by 4, which is 3%. All right, so that's all right, and let's have a look. So this time we've got, if we've got the rate per quarter, then what we're going to need is we're going to need the time period. So we're going to have to know how many quarters there are. Okay, so we've got 4 years, and there's 4 quarters in a year, so that's going to be 16 quarters. Okay, and now let's go ahead and work out how much it is after 4 years. So let's use the formula for the compound interest. So notice here, this is how we're going to find, we need the rate per quarter. So that's where we've found that in part A. So 3 over 100, you can put it in your calculator like this, and that's to the power of 16 quarters. Now, if I go ahead and put that in my CAS calculator, we can go now. Let's go ahead and do that. So we start off with $50,000, and we found our rate per quarter. So let's go control divide 3 over 100, 3% per quarter. And that's to the power of 16. That gives us $80,235.30. Okay, now it says determine the total interest. Well, you can see that this is the total amount. So the interest, how much interest have we earned? Well, we've got to subtract the principal from that amount, so $80,235.30. And if I subtract my principal, that's how much interest we've earned, which is $30,235.30. All right, now let's do this one. This is a sort of a typical exam style question. We want to work out which one of these rules applies for this. We've got $80,000, 6% interest per annum, and let's work out, well, which one of these doesn't look right? Well, first of all, this one says 8,000, so we can cross that out. Also notice that just looking at these, this would actually mean you're losing money because we've got a value less than 1. So that's not right, and that's not right, and actually that's not right. So technically it's this one, but why is it that one? Because we've got the inside the brackets, we're going to have 1 plus the rate per annum is 6 over 100. And that as a decimal is 1 plus, let's get the decimal point, 1, 2, that's going to be 0.06. So that's going to be 1.06. And of course that'll be after n years, so there you go. That is our answer for C. Now let's look at one where we're looking at compounded monthly. So we've got $8,000 over 5 years. So we're going to have to work out the interest rate per month. So if I'm getting, look, it's not going to get 12% per month. We're going to have to split that rate up. So we're going to have the rate per month. The rate per month is, we're looking at the yearly interest rate and we're dividing it by 12. So that's going to be 1%. How many time periods? Well, the time period is, well, we're looking at the interest rate per month. So we want to find how many months there are. So we've got 5 years times 12 months, which is equal to 60 months. Now let's work out how long that is. So we're going to have our compound interest formula. We're going to have the principal out front. And we're going to have, now this is, it's 1 plus 1 over 100. Okay, so this is the monthly rate. We need to know the monthly rate. This is the monthly rate when it's compounding, not the yearly monthly rate. And then we're going to have over how many, this has to also be in months. So we're looking at to the power of 60. Let's put that in the calculator. So you can do it exactly like this. You can go, okay, 8,000, 1 plus, let's start a fraction, control, divide, 1 over 100. No need to even convert that to decimal if you don't want. And we can do that to the power of 60. My calculator's in a bit of a funny mode. So, $14,533 and 60 cents. All right, now I probably should have my calculator representing a few more decimal places than that. So technically I could go, let's go to settings, and I've got float 6. Let's go float 8. So if I was to do that again, then yeah, that's looking a little bit better. So they've actually rounded that to 1. So that's a float 6 before was giving me 6 figures. Now I've got 8 figures. Okay, so 14,533 and 57 cents, I guess, would be more accurate. All right, now let's look at comparing interest, because now that we have looked at all the different compound interests, let's have a look, and we're going to talk about this concept of simple interest. Now look, realistically, we want compound interest because we want compounding on daily, monthly, quarterly. But you know, we will ask you what is the simple interest. Now the simple interest is a completely different formula. Okay, and that's going to be, so it still uses the principal, the rate, and the time, usually in years. And of course, we can work out how much interest is earned. But see, what happens if I have $1,000 and I earn 10% interest? The way compounding works is, 10% of 1,000 is I've got $1,100, and all of a sudden I've got 10% that I'm earning on that, and I'm earning 10% on the new amount. Well, simple interest doesn't work that way. Simple interest is just simply, if I'm getting 10%, I'm getting $100 per year, and that just is what the interest I'm earning. So, of course, we want compound interest. So let's go ahead and try some of these examples. So whenever we've got simple interest, we're going to have to use this formula. We can't use the compound interest formula. Okay, and that's sort of represented here as well. All right, so let's go ahead and do this one. We've got, first of all, let's compare them. Now notice that this is actually a good comparison because they both have the same rate. We've got the same principal over the same amount of years. Okay, and we can say that we're only compounding once per year, but we're actually investing on that growth. So first of all, this first one here, we're going to use the the compound interest formula. So we're going to use this one here. Okay, the principal is 5,000, and the rate is 5%. So that's 5 over 100, and we're looking over 3 years. All right, so if I go ahead and do that in a calculator, I'll have to work that out. So we're looking at 5,000 times 1 plus 5%, or 5 over 100. Let's do that to the power of 3. We want it as a decimal, so I'm looking at $5,788.13. $5,788.13. That's compound for 3 years, and it's once a year. Now let's have a look over here. Let's work out if it's, so when you say simple interest, we're going to have to use this formula up here. So, but we're going to actually, when you work it, you're going to notice that we're going to get a value much less than this, and that's because we're just working out how much interest we've earned. So let's go ahead and do that. So the principal is 5,000, so it's 5,000 times the rate, which is 5% as a percent, and the time is 3 years, and we're dividing that by 100. I reckon we could do that without a calculator, because 5 times 5 is 25, so that's 25,000. 75,000 divided by 100. Well, we could cancel out those 2 zeros, and what we're left with is $750. Now, of course, it wouldn't make much sense to invest 5,000 and you've got 750. That's because this is how much interest is accrued. So what you have to do with simple interest is we have to add, the amount that we have after earning that interest is we need to add that to the principal. Okay, and the principal, we started with $5,000. So it's 5,000 plus 750, which is $5,750. Now notice that these are exactly the same rate. They're both 5%. They're both the same principal over the same amount of time. And as you can see, we've got about $38.13 more just by compounding annually. If you compounded monthly, we'd have even more money. All right, now I'm going to leave those up here, and what I'd like you to do is, I've got a very similar question down here. I'd like you to have a go at this question. I'll pause this, have a look up here, have a look for a similar question, and if you can, see if you can do this yourself. All right, pause it now, and I'll reveal my solution in a second. All right, so I've done these now, and as you can see, I've got exactly the same interest rate, exactly the same principal over the same amount of time. The first one is when we're looking at compounded just once a year. So the rate per year is 6%. So it's 1 plus 6 over 100, 3 years. So 3 years. And that gives me $4,764.07. Now, of course, that's going to be more than, it's actually about $44, a bit over $44 more than simple interest. So simple interest, first of all, we've got to use this formula, I equals PRT over 100. And let's put that in together. I did this one by hand because we're looking at 72,000 divided by 100, cancel out 2 zeros, that's $720, but you can use a calculator. And then I'm adding that to the principal, so we've got $4,720. So look, this is a common thing we'll ask. We'll sort of ask simple interest, we'll ask compound interest, and we'll want to compare them. Okay, so this is what this exercise is about, is comparing them. All right, now what I'm going to do is on the last page of your notes is you can see that we've got a typical exam style question. Exam 2, the one with your calculator, in particular you'll need a calculator for this. And what we've got is Jessica decides to invest her money. Now she's got $12,000, so she's got the same principal, and she's investing over the same time period, 5 years. But we're going to look at 3 different options. So option 1, she invests her money at simple interest. Okay, so that's really important. It's simple interest, so we're not compounding. We can't use the compound interest formula. And it's actually at a higher rate at 7%. Now, we're also looking at another option 2. We're looking at compound interest, but it's only compounded annually, and it's 6.3%. And finally, we've got she invests her money at a slightly less rate, but it's compounded daily. All right, so let's go look at each of these options. So let's look at the first one. Well, the first one is if we're earning interest at simple interest at 7%, let's first of all write out the right formula. We want to use a simple interest formula. This is just going to work out how much interest we earn in that time. So the interest, the principal, she started with $12,000. So 12,000 times the rate, it's 7%. The rate's different for each of them, and we're looking at over 5 years. Okay, 12,000 times 7, 84,000 times 5. You can use a calculator, but I'm looking at what, 420,000 divided by 100. I reckon I could do that without a calculator if I was to have that. 420,000 divided by 100. Let's cancel out those two zeros. So we're looking at, we've earned $4,200 in interest. Now, we started with $12,000, so of course that interest is how much we've earned, so we've got to add that to the principal to find out how much we have after that time. So we started with $12,000, so if I add 4,200 to that, that's going to give us a grand total of $16,200. Now notice that this one here, 7% is our best rate. Okay, but it's simple interest, so it's not compounding, which is really powerful. Let's look at option 2. So option 2, this time, it says that it's compounded annually, so it's not too bad. So our time period is annually, which means we're looking at our rate per year. Let's write out this, so the rate is 6.3% per annum. And, the time is equal to, we're looking at this over 5 years. 5 years. And let's go ahead, we've got $12,000 is our principal. Let's use the compound interest formula. It's going to be 12,000. And the rate, well, it's just 6.3 over 100. Okay, and then we're doing that over 5 years. So this is the simpler one because everything's in years, so we can just go ahead and put it straight into the compound interest formula. Now, if I go ahead and do that, let's do that in a calculator. You can just do it straight like this. You don't even have to convert this to a decimal if you use the CAS calculator properly. So we're looking at 12,000. And then we're multiplying that by 1 plus. Let's put our rate to control divide. Let's start a fraction. We're looking at 6.3% or 6.3 over 100, and that's to the power of, we're looking at 5 years. So we're looking at $16,287. So we're looking at $16,287, and I think it was 43 cents. So far out of those two, we're compounding 6.3% annually. That's going to give us better than the 7% of simple interest. Okay, so far we're looking at option 2. Well, let's look at option 3. Now, option 3 is a little bit more tricky because, yes, we're using compound interest. We've still got the same principal, which is 12,000. We do have a rate which is lower. It's 6.2% per annum. So what we're going to do is, though, here's the important thing. It's compounded daily. So we don't want the day. So it actually looks at this rate. It'd be nice if you get 6.2% per day. That would be fantastic. It would be rich really fast. But we're going to have to divide this. We're going to have to find the rate per day. So what we can do is I'm going to get that 6.2%, and we've got 300, let's not include leap years, 6.2%, and if I divide that by 365, then I'm going to get my answer. Now, I think here's a really important thing. If you start doing the rounding off early, you're going to get a different result. So what I'm going to do is that rate, I'm just going to leave it as this 6.2 over 365. I'm going to put it in my calculator and let the calculator do the work. If I do any rounding, it's going to be quite a big difference when we're looking at investments. So let's try to keep it exact. So this is a percentage. It's going to be whatever that is in your calculator. Okay, now let's look at the time period. Now the time period is also going to change because I've now got this is my rate per day, whatever we get for that. 6.2 divided by 365. So the time period, we need to know the amount of days. Well, we've got 5 years, and there's 365 days in a year. So what's that? That's going to be 1,800, 1,825 days in 5 years. Now, let's go ahead and put that all together. So we start off, same thing as before. Got our principal out the front. But this time our rate, well, we don't want 6.3. We've got, it's 6.2. So we've got to get 6.2 and we're dividing that by 365. That's the rate which goes on top. And then we're dividing it by 100. Okay? And this is the rate per day. So this is the rate per day. So what we want to find is we need to have how many days. So that's 1,825 days. Okay, so if I go ahead and put that, I can put it in the calculator exactly like that. Look, if you're going to do it, you might as well not do any rounding until right near the end. So let's go ahead and put this in our calculator. All right, so we're looking at 12,000. We're looking at 12,000. We've got a rate 1 plus. Now, I want to have a fraction on a fraction. So if I go Control Divide, brings up the fraction tool. And if I do it again, Control Divide again, that's actually going to bring up another one. So as you can see, it looks a bit ugly, but if I do 6.2, we've got 365. We're going to split that up. There's my rate per day. And if I just put it in a calculator like that, and then we've got to the power of, well, we've got 6 years. I could even do this if you wanted to. You can say, 5 years times 365 days. Now, if I do that, that's going to give me $16,360. That's going to be $16,360, and I think it was 76 cents. All right, now, as you can see, which option would we invest in? Well, you'd clearly go for option 3, although it shows the sort of power of compounding. Banks sort of compound interest every day, but you get paid a month. There's a reason for that. It's because they're making more money. But you can see there that we've got, this is clearly the best option. We get, about $73 more than option 2, even though we've got a lower rate. We've got 6.2% compared to 6.3%. All right, now, this is a very common exam question. You're going to get something like this every year for financial, in your tests and the exam. So it's really important to sort of understand the difference between simple interest, compounding maybe annually, and the more complex, looking at things like daily compounds, monthly compounds, and so on. All right, that's about it for me. You'll probably need to practice some of these questions from your coursework, comparing interest, but make sure that you have this jotted down because, this is a really common sort of question that you'll get in your tests and exams. Right. All the best. Take care.